Good morning, everyone. In today's lecture of our Unit 3, we are going to see about the topic decomposition. In the last class, we have seen about the schema refinement. In that schema refinement, we have seen about the redundancies and the problems are going to cause with the redundancies, right? In the problems, we have seen the problems like anomalies. We are facing some issues while insertion, updation, and deletion, right? So we have seen the examples of insertion, deletion, and update anomalies also, and how to overcome those delete and update anomalies with the help of delete cascade on update. We have seen that, right? So one more topic for to overcome the problems of anomalies or redundancy is decomposition. What do you mean by decomposition? Decomposition is the process of breaking or dividing a single relation into two or more sub-relations. So what is the decomposition? It is breaking down of relation into two or more sub-relations. What do you mean by relation? A table. In simple terms, I can say it as a table of a database. So if we are putting a data in a single database, then we're going to face a redundancy. That means duplicacy, right? Is going to be avoided. So to overcome those problems, what we are doing, simply we are decomposing our tables into further subtables. So when a relation in a relation model is not in the appropriate, that is not in the normal forms, then we are going to decompose. What do you mean by normal forms? We'll see when we're going to cover the topic normalization. Already we have discussed about this in our labs. So we have seen some three normal forms. So later on, when we are going to deal with the normalization, we'll see about the normal forms also. Okay, so what it's going to do in a database is going to break the table into multiple tables. Okay. And when we are going to do this, if this relation has no proper decomposition, that may lead to the problems like loss of information. Means if we are not going to, when we are going to decompose, if we are having some issues like insertion or deletion anomalies, or if we are having some issues like duplicacy at that time, so whenever user sees the data, it cannot analyze what's the actual data is about. If he's having duplicacy, that row is okay. If I, for example, if I take a student details, in the student details, I am storing the student details as well as some course detail within a single table. And what I am doing is one student taking one course and the same student is taking another course. So how many subjects are there? That many, that details of that students is going to repeat in row by row, right? And some for some students won't take all the subjects, just they choose only two or one subject. So when we are entering, it is not easy to analyze how many students are taking how many subjects or how many are going for one subject. We can't analyze by seeing the data. Why? Because some rows will be duplicate, some will be only one, not repeated. So the user cannot easily understand that data. So the best practice to get analysis of data is to decompose the table into two. So what we'll do, how many students are there? We'll maintain one table to note the student details, and how many subjects are there? We'll maintain one table. So in that, we won't repeat any student details in student information table, or we won't repeat any course information in course table. One subject will maintain one single row. So that is easy to understand. But what we'll do, just we'll relate that table with the help of some primary and functional keys. Sorry. Okay. We'll relate that table into some relations. Okay. When we are going to relate, we can easily understand. So that's why we'll use a decomposition so that we won't lose any information of our table. Okay. Decomposition is used when it's going to use to eliminate some of the problems, that is like anomalies, inconsistencies, redundancies, right? If we are facing these, only we are going to decompose. Now let us see properties of decompose. The following two properties are there, that is lossless and dependency preservation. What do you mean by lossless decomposition? Lossless decomposition ensures that when you are decomposing, when you are splitting, okay, when you are splitting a table into other two tables, there should be no loss of data. There has to be a no loss of data. Whatever the data is there in your base table, the same data has to be there in your splitted tables or subtables. Okay, and if you are rejoining that two subtables, then it has to resemble your same base table. That leads to lossless decomposition. If that thing is following, then we say that kind of decomposition is lossless. Okay, next. Dependency preservation. Dependencies means what? Dependent. What do you mean by dependent? Means one attribute value is going to be depend on another attribute value. Means if we are changing one value, obviously the other attribute value is also going to be changed. Then only we'll say that those two attributes are dependent. Means one is dependent on one another attribute. So what do you mean by dependency preservation? Okay, none of the functional dependencies that holds on the original tables are lost. Means on the base table I am having some functional dependencies. For example, again I'll take a student table, okay, in which I'm having attributes like student number, student name, okay, student address. So if I say student number is a primary key column for my student table. So based on the student number, I can write a student name, student address as a dependence, right? That means based on the number, I can say the S name and S address are dependents. Means these are functionally dependent on first column, that is student number. Okay, so if I'm splitting this into some other tables, that functional dependency should not be lost. This is going to be checked by dependency preservation. Okay, if we are splitting course ID and course name also there, so course ID and course name both each are dependents, right, on each other. So if you are maintaining a separate column, then what we are doing for student table, we are maintaining functional dependency of students, like student number is dependent, student name and all. And for second table, we are taking it as a course number and course name. So in two tables also functional dependency is maintained. Either of these two table is maintaining them from the base table. So this will check by the dependency preservation. Though, so what it's saying, the sub relations will still hold or satisfy the functional dependency of the original relations. Types of decompositions. We'll see how many types are there. Two types, that is lossless and lossy. Lossless joint decomposition and lossy joint decomposition. Again, lossless can be defined as lossless decomposition, dependency preserving. What do you mean by lossless? We'll see first. So lossless. If I'm saying, okay, if there is a relation R which is going to be decomposed into sub-relations like R1, R2, and so on up to Rn, these decomposition is going to be called lossless when the join of sub-relation results in the same relation R that was decomposed. What do you mean by this? Okay? If I'm saying, okay, R has what I am saying here is if R is divided, okay, if R is divided into some sub relations like R1, R2, and R3, okay, so it has been divided. If I again rejoin this R1, R2, and R3, it has to give me the same base relation R. Then only I can say that that is lossless joint decomposition. Means whatever we are splitting, again if we are able to rejoin those sub relation and form a base relation, then that type of decomposition is going to call as lossless. Means no loss of data is going to be occurred. For example, we can see here, consider the following relations. That is, one relation R is there, means table. Relation means table, in which way I am having some attributes, means columns like A, B, and C are there. Okay, this is your relation. You can see on your screen. So I am decomposing this. Okay, I am splitting into two tables, one R1 and R2 sub relations, in which I am maintaining AB attributes, here BC attributes. Okay, so that means I have decomposed, okay, into two tables. Now later if I join this, how we will join? With the help of common attribute, right? If we are having a common attribute, we can join easily. So again, if we are rejoining A, B, and C, what we are doing? We are getting a actual R, that is base. Base table again we are able to get. So as we are going to able to get the same relation of that base, of joining a sub relations, then we are going to call this type of decomposition as a lossless. Why? Because we have no loss of data here. Okay. Next, dependency preserving in your lossless join decomposition subtopic. Okay. So what is dependency preserving? It is an important constant of a database. Independently, at least one decomposed table must satisfy every dependency. Just now I have said, okay, if we are having any dependencies, functional dependencies, means one column is depending on another column, like student name is depends on student roll number, right? Because in colleges, students are information are stored with the help of roll numbers only. Now, so the other columns, what we are mentioning is obviously it's going to be functionally purely depend on your student number only. So if I'm splitting those student details further, those functional dependencies should not be deleted or should not be skipped. We are saying in this dependency preserving. So what it's saying here is, if a relation is decomposed into sub-relation, either of these R1 or 2 must be should have that functional dependency. So that dependency should have to be in R1 or it has to be in R2. For example, if I'm saying R is having a functional dependency as, here you can see A. Okay, A is determining BC. So DC is the dependent, A is the determinant. Okay, A is VC is going to depends on A. So this relation is going to be decomposed into R1 and R2, which is the following dependency I can maintain in this ABC as, again I can maintain now because it's having ABC columns. So I can maintain as functional dependency in my first table as A to BC. We are going to read functional dependency as functional dependency A to BC. This arrow represents 2, A to BC. Means A is a determinant, BC are the dependence on A. So A is a part of R1. It is not there in R2, but it is a part of R1. So we, by the definition itself, we can say that yes, it is present in R1. So it is dependency preserving. It is preserving that functional dependency here. Let us see with one example here. One table is given to you, that is employee project details table is there, in which you are having employee code, name, email, project name, and project ID. So here project details also in the same table, employee details on the same table. If my 101 again taking another project, again I need to maintain one more record, right? So it is somewhat not analyzable, right? Not analyzable. If we are having some thousands of records of students, then it will be headache to find which employee is belonging to which product, right? So the best practice for this is to decompose this table. So we can decompose how? Yes, we can decompose by maintaining employee information in separate table and project information in a separate table. So here you can see in this what we can write a functional dependency as employee code. Okay, if I know just now I have said the example of students now, student number is important thing. So here employee code is important thing, which is determining employee name and employee email. And project ID is there, which is determining project name, right? So these are the determinants, these are the dependents. So first we'll split this table, decomposing table. After decomposing, it is looking like this, in which we are maintaining employee information and project information. And one important thing in between those is to maintain a relation between these two tables, one column sure has to be a common. So here we are maintaining one common column is a, sorry. common column, we are maintaining here it as project ID. Okay, so in which we are having a functional dependency as employee code to employee name and employee email. In second table, I'm maintaining it as project ID to project name. So as I have split it also, I am able to maintain functional dependencies, right? Isn't it now? Here also I am able, here also. So we see that all functional dependencies are either part of employee or project details. So decomposition, this type of decomposition, we can say it as a dependency preserving, means it is maintaining the functional dependencies. Whatever the dependencies are there in the main table, these are going to be maintained in your subtables. Next type of decomposition, that is lossy join decomposition. First we have seen lossless, not lossy. Lossy means what? Means there can be a chance of loss of data, or we are not able to maintain any functional dependency in this type. So let us see with some one examples here. What I'm saying here, okay, we're maintaining a relation and we're decomposing into some R1 and R2 as like pre-rare one. So this decompose is going to call as lossy join. Why? When we are again joining this sub-relation, it not going to result in the same relation as it was previous. Okay. So the natural, if we are performing any natural joins, last also we have performed the natural joins also. In that also, here also, if I are going to perform any natural join function, which we have seen in earlier classes, in your second unit, if we are going to perform this on the sub relation, the final relation what is going to we'll get is not as a same of your base relation, means prior relations. So these types of is going to call as lossy join decomposition. So what we can get is this: if we split this main table into sub relations, if we rejoin with the help of natural join, we can get some extra tuples or we can get some less tuples. That can be possible. So that means that is a loss of data. So consider this relation, the previous relation, that is base relation. Here it is the divided into two relations, R1 and R2. Okay. Lossless, why? Because again, if we are joining natural join, okay, so as you see here, if we are joining this, we are getting the relation bottom. You can see here we are getting not X like this. Where it is, just a second. Okay, leave it. Where it is. Yeah, okay. So as we are able to join this, we are not getting the same same relation fit. We are getting some different tuples here. Okay. Next, problems related to decomposition. So we will have seen the types of the decomposition. Let's go for the next topic, that is problems related to the decomposition. If relation has no proper decomposition, it means if we are unable to decompose it properly, then it may lead to the problems like loss of information. Okay, that like lossy decomposition. Decomposition used to eliminate some of problems like Anomalies, inconsistency, and redundancy. If we are unable to make the proper decomposition, that leads to these problems. So, as we are decomposing a relation schema, many problems are going to be solved, but there going to exist two questions we need to ask. That is, do we need to decompose a relation first? Do we need to decompose a relation first? Or if we have decomposed, what problems is going to occur if we are splitting those tables? These are the two problems we are going to exist in the decomposition. So for the first question, we are having a several normal forms in our normalization topic for relation. If that relation is in one of these form, so certain kinds of problems cannot arise. Means if we are not having any duplicacy of data in my table, okay, I am maintaining a separate attribute, separate values, okay, and it is easily to analyze, then we need not to go to for a decompose. Right. So this problem has been taken care there. If the normal of a given relation schema help us to decide whether or not to decompose the further. If it is sure, if it is of a in every normal form, so we should not decompose it further. If we decided that it has to be decomposed, we must choose a particular decomposition, that is a lossless or lossy or dependency. Either of these we need to choose. With the respect for the second version, that is, what problems does given decomposition cause? So related to that problem, the lossless join property enables us to recover any instances of the decomposed relations. What do you mean by that is, the lossless, with the help of the lossless, if we are splitting this relation into sub-relations, then it is possible to join those sub-relation again, get back the base relations. So we are not getting any loss of data. So we are preserving here our data, as well as we are preserving dependencies also with the help of dependency preservation, right? This means if we are having any enforced constraints, means some of the constraints already decided or described on our relations, those are not going to be skipped. That was going to be repeated in the sub relations also, as we have seen in the dependency preservations examples, right? Function, we are able to preserve the functional dependencies, right? So the second questions what we have asked is also going to be clarified here. Now, but one serious drawback for this decomposition is that querying. Means if we are querying a table, if I am giving a select asterisk, okay, select asterisk from so and so table. So what it get? It will get all the columns of data. If I give on some where conditions, okay, select particular column on particular condition. So it will display that particular column based on that particular condition. But now we have decomposed R into some R1, R2, and R3. Okay. Now, if what the queries I'm putting to main table, that queries I can't put to the same subtables, right? Because it has been divided. If I want to put the same query for R1, R2, and R3, what I supposed to do? I have to supposed to relate those data first with the help of some primary and foreign keys, right? And again, when I'm querying the data, okay, based on the relation with R1, R2, and R3, what it is going to be do at the backend? Again, joins is going to be performed, right? Same again at the backend, it's going to perform a main table only, right? This is a waste of time, right? So that is a performance penalty of decomposing, not which is not going to be acceptable. In this case, without decomposing, we can use uh, some constraints, or we can reduce some redundancy by putting some check condition, or by putting some constraints on columns only. So we can put a genuine data in our base table only, so that we can query directly. So this is one kind of problem, but it is not going to work for the all data. Why? Because if we are thinking of a small example, it's okay. If we are thinking of a student number and student course details, okay, that's going to be work fine. But within a single table, if I am holding organization data, means for a college purpose only, if I'm maintaining a separate department data in a single table, at that time it's not going to be work. We are sure we are supposed to decompose only, right? If we are thinking of only particular section students with particular subjects, okay, we can count on the fingertips. We can say, okay, these many courses are there, okay, we can maintain in Excel sheets also, that's not a problem. But if you're having a larger data, so the best practice is to go for the decompose only and to maintain some functional dependency with the help of dependency preservation and lossless only. So this is what our problems related to your decompositions. So we have covered till now schema refinement, okay, the problems with redundancy, decomposition, and problems related to decomposition. Next topic, the important topic in your third unit is functional dependency. It is the most important topic. Why? Means as you going to know about the functional dependency, then it is easy to understand the topic normalization. Normalizations, totally all normal forms are going to depend on functional dependencies only. So what do you mean by functional dependency? Functional dependency is a relationship that exists when one attribute determining another attribute uniquely. So, dependence. If I say, okay, if I say in mathematics also, dependencies is that if I am having a two columns, right? General topic for general dependency, I'll say, okay, if I am saying okay, in my table, two columns are there, that is X and Y. If I'm saying okay, in my table, I'm having two columns, okay, that is one is X, one is Y, okay. What do you mean by X and Y? If I say X is determining Y, what do you mean by in mathematical term? What it's we'll say key Y is going to be determined if we are having any function, like if I am saying 2x, okay, 2x is there. So whatever the value of x is there, if I am multiplying by 2, I am going to get the values of y. Then only we will say that x is determining y. Okay. So if I am having the value as 1 and 2, I am getting here as 2 and 4, right? This is going to work in your mathematical function, right? Means if I'm knowing the values of x, I'm going to get the values of y. Then only this is the meaning of okay, x is determining y. But in DBMS, this is not like that. We will have the table which is having x also and y also. Means x we are having some values 1, 2, 3, and here also we are having some values like 4, 5, okay, some 6, and then I can take it here as 1 also, 1.7, okay. So already we'll have some x and y values, okay. So now we are supposed to check whether my x is determining my y or not. So here, if I'm saying okay, y is dependent on x. So here you can say 1 to 4, 2 to 5. Okay, we are going to get the data is 1 is determining the value 4. Okay, 2 is determining the 5, and 3 is determining 6. Again, I am having 1 is determining 7. So in this case, now functional dependency is going to be failed, right? Again, 1 is determining 4, 1 is determining 7 means that's not correct, right? So we can't say that is it is functional dependent. So what I'm trying to say to you is, okay, we will be having some data already. Table will be there. In that we are supposed to check whether that column is purely functionally dependent or not. Means if we are getting, if you're choosing any particular value of an attribute, whether that value is determining the other attribute value or not, we are supposed to check. So that is going to be checking your functional dependency. So functional dependency is a form of integrity constants that can define schema with redundant storage problems and to suggest refinements. If we are having a duplicacy data, then that data is going to be refined with the help of functional dependency. Just now I have given an example. Now, 1 is determining 4, 1 is determining 7. That's not a correct thing. So first of all, the refinement is going to be taken. Then we are going to define a functional dependencies. How we are going to define, we'll see in the next class. We are running short of time now.